Okay, so let's make a start. Um, I can introduce myself first, maybe. Um, at the moment, I'm the head principal head of a middle school, and then a head of many other departments as well. My interest in this is for the last maybe 15, nearly 20 years. Interested in what's going on in the universe, what's going on around me. So I've gone down all sorts of rabbit holes, maybe close to where you are now, some of you, and then decided I'm wasting my time. So I'll just start studying science and improving myself. So that's where I am now. I love Buddhism, Christianity, Sufism, all the isms, theology, and then at the same time, science. I'm probably a materialist, hard determinist. Um, I love rational reason, and I love debate, and I love seeing people learn something new. So this is why I'm here mainly. That's me.
Cool.
Someone else wants to go.
Sure, I can go. Yeah, I'm Josh. I mean, see me on the other Flat Earth videos here with Outfox Studio, and um, it's always nice to be invited back on to just kind of present the Flat Earth view as I know it, with the best kind of open-minded approach and reason through some of these things. I've been flat Earth proponent for about 7 years, and I consider myself to be a biblical flat earther. As I've said before, I'm 32 years old, father of four boys, and happily married, newly married for about a year and a half now, and live out in Wisconsin, right by beautiful Lake Michigan, and yeah, ready to have another fun conversation.
All right, now we'll go next. I am Brad. I'm here basically because it's like I love psychology, sociology. I like the way that the mind works. I like how we can, implement different ideologies. And I'm just kind of interested in more like what makes us tick psychologically and what makes us believe something. So I find that very interesting. Other than that, I come from a musical background, and I also work in the financial industry, which is also an eye opener in terms of human sociology as well too. So just I think we all kind of bring to the table some varying, different, interesting elements for sure.
Yes, we do. My name's Keith Dixon. I own my own company, K-Rock Chairs. I've worked heavily with permanent magnets. I'm an inventor. Been looking into all this stuff for well over 10 years. Every avenue, pretty much my whole life at different aspects of what's going on in the world. I'm trying to just grab at the facts rather than sort of stumbling around believing what you're told by the mainstream. So yeah, it's a sort of I'm not a religious flat earther into flat earth because it's something where you can actually expand your mind once you understand what you're actually dealing with. So yeah, that's it.
So I'd love to hear maybe whoever'd like to go first, either Keith or Joshua. The best. What's the most convincing argument for you? What's the most convincing thing for you? How convince me?
I think you've got to take water into account as being the biggest proof. And then you just every device that we use, from a periscope to a compass, sundial, level, gyroscope, sextant, astrolabe, all these things have been around for thousands of years to measure your way on a flat plane, not for anything else. A sextant, you use a triangulation of a star and the flat plane that you're standing on. So you've got two straight lines, the one you're standing on and the other straight line that goes off to the star. Now that doesn't work on a ball. however you want to put it, it doesn't work on a ball. You've got to have those two straight lines. And your ball tells you that that C's bent, and you've also got a bent surroundings above you visually. So, just things that have been around for thousands of years wouldn't have been created if you weren't living on a flat Earth. And water is just undeniably the biggest proof. There's 30% land, 70% water, and it's all flat wherever you look. If there isn't enough flat land on land, you've just got to go to the sea. And, the most mapped out, the largest flat area that we know is the abyssal plain, and that's under the sea. And that's been well known since submarines, a mapping of the sea. So it's there. It's just there. It's just so simple, so simple. And when you look at the other side of things, when you look at the ball catastrophe of an explanation of why we live here and why is everything, it's been made up all along, and they just keep on adding to it. It was the fundamental framework of astrology. It was wrong in the first place, and they just keep on building on it. It's never going to be correct, and you can't correct it with dark matter. All these things, it's just ludicrous. All the stuff that they bring to the table to tell you that you live on a ball, when the reality is you walk outside and you see it's flat and it is not moving. If you put it to the test, by all means, I beg anyone to go out there and prove that they live on a ball.
I think the biggest proof then otherwise would be your first visit to space, if you had enough money.
Well, this is another sort of lie sown to us, along with the ball theory, is that space is nothing more than a theory.
I mean, you yourself, if you went to space, you saw it was a globe, then your mind's changed instantly.
Yeah, well, I've seen enough high altitude footage and enough fake NASA footage to make me jump to one side or the other. When true balloons are being released all the time, and the footage is being shown without a GoPro camera, and everything's flat, 22, 23 miles up. And then you've got NASA who shows it instantly bendy as soon as this fake bloody firework takes off.
If I want to go back in a minute to the water, but the first thing I want to go to is the NASA footage. One thing, like the fake NASA footage, one thing that you can see in every NASA picture of the space is everywhere circles. There's no flat anything in space. Everywhere circles. So why would we assume the only thing that's not a circle is what we're on?
And you've sort of fallen apart again. Everything's circles. You mean round? Do you mean round, or do you mean disc circles?
No.
Well, if you're saying everything's discs, then they're all facing us. Why are there none of them that are flat?
Absolutely. When you look at the stars, and you really do look at the stars, you zoom in on the stars, you're only ever seeing one face of them, like the front of a torch. And when you look at the moon, you only ever see one face of that, just shining back at you beautifully. So you just can't automatically assume that everything's a sphere out there. A star isn't a sphere. If you look at a star, they're not spheres. They're jumping around like crazy.
And that's because of refraction, because of atmospheric refraction, which is another.
It's because you're saying about refraction.
It's how we're seeing it through our atmosphere. Okay, you are seeing it through atmospheric refraction. Okay.
Yeah.
So but it's not anything an effect of the star itself or the planet that we're looking at. It's just an effect of the filter that we're seeing it through, basically.
That's right.
So the one point I want to make, you say things are ludicrous, and I don't think that, and I've always said this, a flat earther's disbelief is not proof or disproof of anything. That is just a stance that you are taking. So, I think saying that, water is proof. I mean, You know, it's interesting. When I debate, I don't use props. I have a whiteboard in the background, which I use for business, but I don't even use it for anything. Not to take away from anybody that does, but it's just like, my point is that I hold like official definition as my proof, because official definition has not been displaced or disproven, by any of these theories that are just kind of like, I mean, if flat Earth was real, if the Earth was flat, this would have already transcended being a tinfoil hat wearing conspiracy theory and would be the norm. And I don't believe that, I think that a lot of this is kind of like a rebellion. I respect it as a rebellion. I also, respect that, yes, human nature has a propensity to be corrupt. And I respect that, like people in power, governments, and I respect that. And I mean, it's true that, we live in a system that harnesses us, harnesses our hard work, harnesses our dollar, harnesses the money that we make, and use it for its own interest. But I don't think that, human propensity for corruption should be blanketed blindly, and basically making the connections, drawing the dots and saying, well, the governments lie, humans lie, we are corrupt, so therefore that makes the earth flat. And it absolutely does not. Okay, so it's one thing does not put another thing in its place for the sake of it.
It's
Okay,
the false equivocation fallacy.
yeah, it becomes fallacy. So again, I respect the rebellion of it. And this is why I do like conspiracy theories, because it gives us the ability to kind of gut check the world around us. It gives us a way to gut check our paradigm, and that's a great thing. But I'm very practical. Okay, this is where I draw the line. I don't think that the ability to gut check and the ability to say, hey, let's question everything, necessarily translates to, okay, well, let's put a conspiracy fantasy in its place and try to prove that. Because then all it is just your ego is involved with it. And then, as I was kind of explaining earlier when we were off camera, if you strip away the subject matter of this, what does this become? It becomes just this glorified debate club, where it's just kind of like a high school debate class, and it has all the elements of that. So I think we need to kind of distinguish psychologically, the elements that we're playing with here. There's elements of rebellion in conspiracy theories, as there are any conspiracy theory, which is just bucking the system. But I think it needs to be proven, not just assumed and saying, well, yeah, the government lies, so therefore the earth is flat. No, that it just doesn't happen. Nothing is ludicrous, because you know what? It's not even been proven, or I mean, spherical earth has not been disproven. You can align yourself with whatever belief system you want, and that's fine. But none of this that we're going to hear today actually will disprove it. Guaranteed. Period. End of story. It won't.
I have a lot that I disagree with what you just said, but I also do have a lot that I do agree with. I mean, I do believe that the globe has been and can easily be disproven. I think people are just very, very much don't want to see it. I also don't think, like you said, oh, it has to be there's a conspiracy, so it has to be flat. I think it's more, if it's flat, then there has to be conspiracy. But like I've said in other times, where you don't have to convince everybody working for NASA or they don't all have to be willingly lying. If you just have the bosses and there's only a few select elite people on top that are really pulling the puppeteer strings, and the rest of the people are just sitting in front of a computer playing on a simulation or something, and they don't realize that it's so you don't have to have all of humanity being anyone who believes in a globe is automatically lying or or being a deceiver on purpose or anything like that. There, you know, the nature of being deceived is that you don't know when you're deceived. Especially what I've noticed, and the reason why I speak up about this so much is because I really, first of all, I don't think that most your average flat earther has really any idea how to explain it, and most of them don't understand the globe model very well at all either. And secondly, the information on flat earth is really just nowhere out there to find. The information that you can, that is there, that is like, here, this is a hard fact, this is an important thing. I mean, there was some of the thing, I mean, you asked what was the what are the main convincing proof for me, you know, Francis, and really it's for me, well, Keith said water, right? It's way too vague, but I would say is just the fact that you can see things from really, really far away that you should not be able to see. I mean, I always keep going back to it, the Chicago skyline, but that's not even the farthest thing we can see. There's stuff we can see, like Chicago skyline from across Lake Michigan, about 53.3 miles or whatever. Even with 182-foot elevation, this should not be visible, and the only explanation is superior mirage. But there's been individuals who have gone and shown this can't be a superior mirage because they hold on it and sail their ship all the way across Lake Michigan and keep honed in on it the whole time. Well, there's things that can be seen from much, much farther away than that. And then the other thing that was just kind of sealed the deal is the just there's when you really start looking, like you ask a question, well, how does sun set, sun, or you know, and it, or what about NASA, or what about this, and every single one of those topics, every single one of those questions that I've ever had proposed to me, especially when I was first considering flat earth as potentially valid, they all have explanations that end up being reasonable and valid. And the other thing, for example, like one of the questions you asked, like, well, if all the other things are circular or spherical, like the stars or the planets or the moon or the sun, then how come the Earth is the only thing that's flat? But I mean, without getting into the everything on that one, it like the pool cue and all the 8 ball and all the other balls on the table are round, but that doesn't mean the table's also round. The table's flat. So that in itself is a false equivocation. In the flat Earth model, it's the floor. The Earth is the floor of the universe, and there's a dome over it, and all of those things are circling above. And you don't even need to get into whether the moon is spherical or a disc. Um, it is a very interesting coincidence that we always see the same exact side of the moon and it looks like a disk. And one of the things with the stars that was mentioned, is that it's blurry and they look ripply because of the fact that you're looking through the atmosphere. But I would ask, how come the moon isn't blurry and ripply? And then you have weird questions and things that come up, like the moon is different color than the sun, and there's different qualities to the light,
because
and
the
then
moon
there's
is closer.
explanations for all of
So
these
that
things. There's too many coincidences.
the moon is because the moon is closer. So you kind of give it an evidence of distance then in space. Because the moon is closer, we can see more of the moon because when you zoom into the moon using a camera, so you'll see less refraction because it's closer and there's more of the moon to see. So when you're looking at things much further away, there's more refraction being applied to them because less light is coming from them, and less light
Sure.
can be refracted more by the more atmosphere that refracts. So then
Sure, and
you're
that makes sense too. I mean, that makes sense on the globe model as a valid explanation. And the other thing I will say about the globe model, I think the ball Earth and the sun-centered model, well, it's not really sun, but this, you know, the heliocentric model, is very elegant and you know, it's fantastical and elaborate, and it has a lot of explanations for almost all the questions you might have inside that model. But then when it comes down to just like you start poking at it a little bit, and the reality is nobody ever really pokes at it. You know, most people just take it at face value and they say, oh, it's a globe. That's what everybody says. Oh, NASA went up there. There's outer space and all this. So they don't question it. They assume everybody's done that and they've done that research and it all fits, it all works, and it makes sense to me. So why bother even thinking about it? And so, you'll hear people on TV or news or radio just, use flat Earth as this like ridiculous idea. And that's what's so curious about it. How can people still think the Earth is flat when it's such a ridiculous idea, so to speak? And all of these things have been proven already. And yet, when I went and looked into all those things, it really wasn't. And there is no real good explanation as to why we can see stuff from so far away. On the globe model,
But
it's just
that's
you can't find the curvature of the surface of the Earth. You can't find it.
atmospheric refraction explains why you can see things far away. Like you can see the sun when it's gone down over the sunset because of atmospheric refraction.
Bendy light, yeah, your bendy light. Exactly what I started off with the sextant. You've got bendy light, all right? So
Yeah.
how does this tool work? For thousands of years, you're using a flat plane, you're
what you
using
can do,
two flat lines. You're telling me that you're living on a ball, so that first line can't be flat, and the one pointing up to the star has got to be refracted, so the star isn't exactly where you're looking at it from. It's over there. It's a
Okay.
ridiculous. It's just.
I want to
I
just
could
throw in a little
prove
comment.
it to you right now if you want.
Yeah, just let me throw in a little comment really quick, because it's interesting when I get to this and you start pointing at that and you say it's flat and so we shouldn't be able to see stuff from that far. Suddenly the global proponents want to use atmospheric refraction or atmospheric lensing, but if I use atmospheric lensing and atmospheric refraction as my scientific reasonings for why it's possible for a sun to set on a flat surface, so suddenly that's not for a valid reason for some people, where they're like, that doesn't make sense, and da da da. Well, light bends down, and around. Now, what you're saying is that the light is like orbiting around the curve in the globe model in order to be able to see things from further than we should, because the horizon on the water level is supposed to be about 3.1 miles away, and yet we can see things from much, much, much farther than that. And if you're saying that light bends downward,
yes,
then I get it. You're saying the light bends down, but it bends down into the ball, not around it. It bends down into it.
That's right.
Because it bends through the air, not into the ball. The air is what bends the light.
And it bends perfectly around. So then
not
it
perfectly.
just goes, smoothly. Well,
because it's a sphere, model, it bends as it bends. You know what I mean? You can see it. You can see it when you look into a swimming pool. People's legs are shorter than they should be. You can see it when you look at a campfire. The lights behind the campfire flickering.
Yes, I understand
you can see this directly, and it flickers because of the heat. You can see it on a road. Like you can experience this.
All the same reasons I use to explain why it's possible to have a sunset occur on a flat surface.
But that's the opposite direction, though.
No, if it's flat and the sun's going away, then the light is bending down like this. So this is the rays of the sun, and as it moves away from you, the rays are hitting you. Now you can't see the rays anymore, and they go, even though the sun is still at the same elevation it was before, the light is bending down. So once the light gets away from you far enough, the light source, that downward bend causes it through the atmosphere to no longer be visible on a flat surface once it goes far enough away.
You can see it until it's here, and when it goes down, you can still see it
visibly. I'm saying, but a sunset, eventually you can't see it.
Yeah,
right?
Because it goes down further because we're living on a globe.
Well, see what you just did there, though? That's a strongman argument. That's like a strongman argument, because on a flat Earth model, if it stays here and it's just going and going and going and going and going, and the light from that is bending.
It's not. It doesn't bend like that. It's not.
Hold on. Let me finish, because it will basically appear to go below the horizon like this. That will appear that way, and you can do it on a kitchen table using a lens and all this. You can make something that's above the table and stays above the table the whole time, and you just move it away from you, and you put a lens in between you, it will appear to stay the same size visually, and it will set. It will drop below the line of sight and look as though it disappears.
Yeah,
I have a question. Okay, so let's kind of talk about the track of the sun. Okay, let's talk about the trajectory of the sun itself. You know, and I understand about lens, you know, the lensing and the atmospheric refraction. I definitely understand about that. I just don't think that the effect of lensing and atmospheric refraction will. I mean, you were talking about something here. Let me use this as an example. I am going to use a prop actually. How do you flip this around? Is there a way to flip this thing? I'm not familiar with Skype. I'll flip my phone if I have to, but I just kind of want to try to flip it. Yeah, I don't know. This Skype is just not with it.
See it on my end either. A way to flip
Yeah.
the phone. Oh, wait, if you look at your little picture and click on it.
I don't have a little picture.
Click on your picture of
Okay.
yourself.
Okay. Hold on. Let me find myself. I don't
Maybe
see.
Keith, you should try this too. That might fix your camera.
It might actually do that.
Not touch nothing. If I touch
You're right,
something,
with technical issues all of a sudden. All right, so I can't even find a picture. Wait. Hold on. Where are I? There I are.
oh,
All right, so it's not going to. Yeah, so I can only see Keith. Hold on here. Let's see here. Oh, wait, hold on. Let me figure this out really quick. Because I'm not trying to hold this up, but I was just trying to do something here. Okay, so anyways, I'm just going to do the best I can. I'm just going to flip this around. So on my balcony here, I actually do have like a little bit of a moon. It's just this little thing that, you know, lights up at night and everything. So kind of little vibe. I'm all into the vibe. I got my little waterfall there and everything. But let's just say that, okay, here's the moon. Can everybody see this? Yeah. Let's just say that this is the sun. Now, unless the flat Earth model is wrong or inaccurate, or it is just kind of a supposed model, the model shows it depicts the sun and moon swirling circularly because it has no other choice. It's swirling circularly above us. And not to make anybody dizzy here, but you know, it's the trajectory would have to be kind of spinning around us. I think if that were the case, we would be seeing the sun and moon. I mean, like literally, like going in a circle, like above us. We would be able just to stand in every direction and just see it instead of. But you know, this is rises in the east. There's the east, sets in the west. I see this every day. I see this every night that I'm here.
It's a really big circle, man.
Hmm?
It's a really, really, really big circuit.
Okay.
And if you go to the North Pole, when you have a 24-hour day, it looks as though, and yes, I know there's an explanation in the globe model for this as well, because like I said, globe model has a lot of explanations for how some of these things work, but it does look as though it's going around you, above you, and you have to turn your head and turn with the sun and look all the way around you, right? But if you're not in that specific place and so I know there's video that claims that there's an Arctic 24-hour day. I've looked into that, and coincidentally, there's an explanation that shows no, look, there's a cut. It's not a full live stream, even though it claims to be. So every time you go and you try and look, there's always an explanation for how it could be faked to try and force it to look like it's supporting globe model. But then when it does that, it's fake. Kind of like when you look at all of these, I hate to get off subject, I'm not going to, but if you look at like the middle link between man and monkey, every time they go look and they find it, they're like, oh, actually, this was a human jawbone or whatever, and it was faked, you know? So, if it's a really big circuit, yes, it's going around, but and it's going westward, okay, but I'll have people say that, oh well, then if it's flat and it's going like this, it should be daytime all day, all the time, everywhere on the earth, no matter what. And that just shows that you don't it's not understanding how big the flat earth really is as well. It's a very, very vast, wide, expansive plane. And to go back to the sunset issue, I drew a little diagram here. Okay, so that's the flat earth, and there's the sun, and it looks like it's making like a little tent. That is the way the sunlight bends down. Okay, so as the sun is moving away, right? If I'm this little guy here, it's going to be daylight for me because the sun is close enough and local. It's still moving flat. Now, this is a side view. So, yes, if I look top down, it's going to be making a really big circuit. Okay. But as the sun moves far enough away and the atmospheric refraction bends that light downward, once the sun moves far enough away, the light bending downward will hit, and this guy won't be able to see the sun anymore. And it will essentially be dark and nighttime for him. Does that make sense?
So can I explore this model a bit? So
yes,
you have your dome. Does the sun stay the same distance away from? So does the sun stay the same distance away from the land at all times, or does it get closer or further away?
I believe in the current model, the sun stays the same distance away from the land. I mean, obviously, natural land masses like mountains and hills, I'm not talking about that. Elevation. So if the land is a higher elevation, like you're on top of Everest, you're going to be that much closer to the sun. But I do believe that the sun is always at the same elevation according to sea level. But I believe that the circuit gets a little wider and a little smaller, which is how you explain seasons.
So then, if it's staying the same level away, when it gets further away using your model, the refraction should make it go everywhere, because it'll go straight to the center and then just send it to the whole globe.
The sun
It'll be
doesn't.
light.
No, I don't
Using the model you showed me, if we're using atmospheric refraction, that means the atmosphere fills that globe. So then, oh, you can't see mine. So if it's the same distance away, you'll have the sun here, and then it will just hit there, and it'll just refract straight out everywhere.
No, I don't understand what you're trying to. Try to explain what you're thinking from a different angle. I don't think that you're explaining what you're thinking.
So
here.
if you had your globe, the refraction you're talking about, where it would go down, could possibly work if the sun was going smaller. If you know what I mean, it followed the globe. If it was getting closer to the edges. No, you have a kind of half globe now. It's not flat, yeah, because you have the
like
dome.
A fishbowl. Yeah.
So if the sun stays the same distance away, and it goes just over there, that means the light will hit the top and then go straight down.
The sun is inside the dome.
The sun is inside the dome.
Yeah.
So how can it go stay the same distance away if it's inside a dome?
The same way your ball spins through space, I guess.
So hold on. Here's the dome. Here's the dome, right? So it goes. I'm going to draw a line side view. Okay. The sun follows a circle and stays inside the dome at that elevation. It doesn't go this way. It goes around. So a top-down view, the sun is going like this.
So what gives the sun its light then?
I don't know. I think that similar to, I think we're like an electromagnetically charged universe type thing. This is greater minds than mine. I don't claim to be able to explain everything. I have no idea about the moon. Okay, so if you ever want to, get to where I just put my hands up, say, oh, don't know, ask me things like what powers the moon, what powers the sun, and what that kind of stuff. I think there are valid explanations for it. I think people like Tesla were thinking, some people say, oh, he was probably a flat earth. I don't think so. I think he was getting into some of the cool, weird phenomenon that can occur. But like circular magnets, I think that the whole earth is kind of like a circular magnet. like giant circular, and there's a north in the middle and south is in every outward direction from the middle. So the North Pole is in the middle. The sun moves in a clockwise direction, like and that's west, and then east is counterclockwise. And then if you go out to the edge, which is Antarctica, and there's not an ice wall. Yes, there is an ice wall, but that's just the shoreline of Antarctica, right? And I think that those land masses on the outside of that go, I don't even know exactly how long. Ask Admiral Byrd. He was one of the only people that went out there and was able to come back. And then it goes, and I think that you find an edge. And I would love not to go up into a supposed outer space, but to get to go out to the actual edge and put my hand on the blue sky ice looking dome edge that boom goes all the way up and over. And I believe the sun, moon, and stars are all inside of the dome and rotating above us. I think that the sun and moon look the same size because they are the same size. I think all the stars rotate around the North Pole, which doesn't move, and that the planets are the same type of object as all the rest of the stars. They just have their own path in the sky and don't follow the same perfect circular path as all the other stars, who kind of look like a big chandelier. The planets used to be known as wandering stars because they look like stars, but they don't follow the same pathway and perfect rotation as all the other stars. And I think stars are cool, and I think it's cool. And see this model, people get pictures of a flat Earth with a boat falling off the end of it, or they'll get a picture of all the planets in a row and then the flat Earth disk three steps away from the sun sitting in the middle, and they mock flat Earth because it's ridiculous, right? How can the Earth be flat if all the other planets are round, right? So, but you're asking from a wrong premise because no one's ever explained at least how the flat Earth model works. And yes, I understand that the atmospheric refraction could cause that light to bend around the Earth and get a little further or whatnot. But it still doesn't explain how it could get so far, that we can see some of these things from so far away that it's like they're supposed to be miles below the curvature, and we can still see things like islands from Italy and houses from super far off. And yeah, you can see them.
We can see the sun when it's gone down over the horizon, and that's how far away is that? So,
well, I think if you go up in elevation, right, then the sun will come back into view on both models. That's the other thing that's so intriguing about this.
You can buy a sunset dinner where you slowly go up, and your sunset lasts for like an hour, I think it is.
Yeah, absolutely. And I think that's really cool. I think that one of the things that's so intriguing about this debate to me is both sides have reasonable explanations for why they see the world the way they do.
And I completely. I'm sorry.
Go ahead.
Yeah, I completely, understand, the concept and the model that you drew, and, it makes sense in and of itself. The problem, though, is application. I think the problem is literally comes down to application, because just kind of going back to basic, algebra here, I mean, you're basically presenting y in place of x, but y does not replace x for the sake of y. So I don't understand where there's got to be some sort of mechanism here that somehow negates the global view here, and not just for the sake of itself, not just for the sake of saying, well, this is what's happening instead. I mean, even though you're articulately explaining, your model in terms of flat Earth, and saying that, well, it's just a big circuit and it's not really rising and setting. It's just nothing you have said has replaced this. It's not replaced what our actual understanding is. And that's the thing. It's kind of like, you know, it's just like if me and you were sitting in front of my house, and I have a street that goes from north south, and you know, we were watching a car go down the street very slowly, kind of like we would watch the sun go across the sky very slow. It takes hours, you
Yeah.
know. And you're going to tell me, well, that's a product of atmospheric refraction that we're just seeing this, or you know, it's just like telling me that, no, Brian, there's that car going down your street, which is going north to south, is actually going east to west because of this phenomenon. You know, it's like you're trying to use you know, something like atmospheric
It
refraction
is. But
in
it's
trying to
like,
kind of to redefine something completely, but there's no catalyst point, there's no trigger, there's no there's nothing in place that it's actually displacing our understanding and putting yours in its place, you know, outside of just you explaining your concept,
sure.
which, you know, you're making it make sense within itself, you know. And I get it, I
I
respect
would
that.
argue that the globe model makes things make sense within itself also. So it's like you're arguing the rules of a video game, right? And so in the globe model, let's say that's a valid. I believe it's a valid theory, a theory, and they're both, I think, working theories, right? The globe can't explain everything, neither can the flat Earth model, which is pretty fascinating. But within the globe model, there are certain rules and explanations as to why things appear the way they appear. You know, they have an explanation for why the sun and moon appear to be exactly the same visual size, right? And why that's such a coincidence that they're exactly, you know, this size and this size, but their sun is exactly further. So there's explanations for that. I would just say they look the same size because they are the same size and they're the same distance away. There's a great light and a little light, and they're there. Two great lights anyway. And then, you know, there's certain things like they have, okay, the seasons on the globe model are explained by the tilt at 66.6 degrees of an angle, and the rotation is going around the sun at 66,600 degrees, and the curvature is, you know, 0.66 feet per mile squared for just the first mile. And after that, you got to get into your calculus and cosine globe stuff. So, and it starts getting really complicated with the, and notice I threw in that little 666 reference in the mathematics of how the globe model works is really coincidental that these things always kind of have these little hidden in plain sight number game stuff going on for their explanations for it. And so what happens is, you'll have an explanation that works in both models, like I say. And so some of it comes down to if you can't explain it right, and both of them make sense. Because I've had people who are like, I can see it both ways, and I don't know. I'm on the fence about it. I've met actually a lot of people about in that position when I talk about this. And so for a little bit of it, it comes down to faith. I do consider myself biblical flat earther. I don't. I kind of don't use the Bible as why I think it's flat. I think that I reasoned and consider it to be flat based on the reasonings that I've gone through on my own. We're not going to have any time to be able to get into every one of the different reasonings. But then when I saw it was flat, I was like, wait, but I thought the Bible taught globe. And then I go back and look at the Bible, and it's like, no, it says the sun has a circuit. It says the earth does not move. It says the earth looks like wax under the seal, and that the sky is hard like a molten looking glass and a tent to dwell in. So these sound like the flat earth model I just described, and not the wobbling, spinning earth. That doesn't sound like it shall not be moved. You know what I mean? So but I digress. I'm getting into the biblical stuff. That was just more of like the afterthought of the flat earth was like, wow, it's flat. So that kind of supports my Bible view more now. And then because my Bible studying and things like that are really very minimally related to flat earth. It's just interesting to me that when I got to flat earth conclusion, I looked in the Bible and it seemed to confirm that view for me.
But isn't there parts of the Bible like Enoch gets taken up into the heavens? He sees the different, like all over the heavens. There's Um, Job was seeing these giant beasts, the Leviathan, and like there's heavens, there's vast
Yeah,
amounts of heavens. So there
more.
is something outside of the globe in the Bible.
No. I would rephrase it and say,
Or
because
the
in the Bible, my viewpoint is that there's the heavens inside of the dome where the clouds are and stuff, and then there's the heaven of heavens, which is what is explained to be up and outside and beyond the dome.
exactly, yeah. So there is things outside of the dome.
Yeah, biblical, probably, like people say, well, what's below the dome? What's above it? This snow globe Earth that you got, and that's something that can't be proven because we can't get out.
No, but then, so our model kind of is backed up by the Bible also. If we're going to use the Bible, then we have a world outside, universes outside, we have beasts, we have God, we have his many mansions, which could be, people interpret that as different planets. And
Anyway, I
So
I don't like getting into the biblical debate on it, Francis, but I appreciate that we were able to kind of go down that rabbit trail a little bit. But I want
Mhm.
you to kind of see how, you know, there's this, if you're coming at it assuming it's a globe, then you can kind of say, well, a line must mean drawing it around like this, drawing a circle like the equator is a line, so to speak. But if you're coming at it from a flat model, I might think a line is like I said, where you'd go from one end to the other and you draw a string and you snap it, and then you're like, this is the distance of how big it
Yeah.
is. And well, the Bible says the earth has four corners. And I'm like, well, a globe doesn't have four corners. A flat circular model doesn't have four corners. So when can we allow allegory? And when is it supporting a view of what the world we live on looks like? And when is it more just like, yeah, four corners is a
so
way of saying from everywhere, so that, but the point I'm trying to get to is, if you come at, and this works not just if you're looking at it from a Bible, but if you're coming at, looking at NASA, if I'm coming at it thinking, well, I think it has to be flat, then everything NASA tells me, I'm automatically going to be looking to poke holes and be like, oh, wait, did you see that CGI? Wow, did you see that glitch? Oh my gosh, different shadow angles on the moon. Who took the photo of the first guy on the moon? Like, oh, look at the size of that continent's bigger than a different one, and wow,
Yeah.
fish islands. And so, but if you look at
It's,
it from a globe perspective, you might just assume that's all truthful.
it's confirmation bias. I agree. But I don't, I'm not looking at it from, so you keep mentioning the word from your globe model, from your globe point of view. I'm just looking from my point of view. And if you could, like, I love the perspective of possibly the sun's inside of the sphere and I'm looking at the refraction, but I still like to see a model where that's kind of demonstrated. If you could send, I'd love to see that. But like Brad was saying, I could invent a world that's completely rational, like we could be in the Matrix. You could just invent Lord of the Rings. We could invent anything that fits what's around us. But until we have like a testable predictions that we can actually use in real life, and you can show that what you're saying is true, no one will be able to believe you. I
I'm
won't be able to
sorry,
believe you.
my phone just, I'm sorry, I'm on a phone and I just had a call come in and it cut you guys. I had to decline it and then it cut you guys for a little bit. So can you just back up
That's
for
okay.
me about
Yeah.
30 seconds?
So if you could get the model, if you could use your model and then show like real testable predictions and prove some of this stuff, like people, if you could go out and prove this to many people, people would really believe it. Like I'd love to see some evidence for this. It would be an amazing thing to know that we are in a flat Earth. Like this is why we're probably interested in this. Brad may be more for the psychological side, but I'd love to know something new. I'd love to know it, but until we can make these
Yeah.
predictions, like when you say
well,
something's far away
I
that
think
we can see it,
yeah,
evidence, some good evidence. Yeah.
Yeah.
yeah, I think
Well, see,
it's just challenging, the paradigm, and that's perfectly what this is about, and just challenging, what we are seeing. But then again, if anything becomes a force fit, then that is bias justification, and so I mean a lot of what is proposed in flat Earth seems to contradict even observable reality, like what we're talking about with the sun and the moon. Again, it's still kind of trying to impart another concept. But again, nothing. It just simply has not replaced what makes sense. And if you want to call it indoctrination, that's fine. But you know, it's also, to believe in flat Earth is also indoctrination. To believe anything, to have any consciousness is indoctrination. To understand your world is indoctrination. We're all indoctrinated. You know,
Yeah,
if you
a
weren't
little bit of
indoctrinated,
a
you wouldn't know how to
product
tie
of
your
our
shoes in the morning.
environment. Yeah, product of our environment type of
Yeah, of
thing. And
course, of course,
yeah,
of course.
you know,
Now, the one thing I wanted to, one thing I wanted to ask. Let's talk about the dome for a second. Let's talk about the firmament. Even if you want to go into the biblical aspects, that's fine. Just let's. There's nothing wrong with going down that rabbit hole a little bit, but you know, kind of the atmosphere versus the firmament, or is there something? What can you give me that is proof that there is a firmament?
okay.
Please.
Sure. Well, now, first of all, I have not jumped that high. So, and so some of that's one of the things that gets really tricky about this. For example, the best way to prove a firmament would be to do what I said I would prefer to do one day and go straight south, not in a plane, because if I'm right, then going straight perfectly south in a plane like that, you might crash into a wall, right? But get into some really heavy snow gear and but and keep this in mind. If you go look, I've had people look and try and figure out how hard it would be to take and drive and do a personally funded trip and get how many different approvals you would have to get and from what organizations and like the army, and there's just so many reasons why they can just say nope, you can't go. But then just to be able to go do what Admiral Byrd did and go out as far as you can into Antarctica, and yes, if you could put your hand Truman style on the wall and be like, oh my gosh, it is there and there's the edge and you can just see that go right. Well, I actually think that there's
But that's
people out there.
fantasy, you know.
I mean, I think there's people out there doing that and researching it, drilling in, and I think it's a blue sky ice thing is what's the rumor out there,
Okay.
and it's like it's a sky ice that doesn't turn to liquid; it just evaporates. But there is another group, a guy that did like a private rocket, and they video and you can go see it, and apparently on the video, but this is all video evidence, right? So but what they said happened is they shot a rocket straight up and it went dunk and hit something and stopped spinning.
Yeah, I've seen videos like that where,
Yeah.
again, like as with most flat
Uh-huh.
Earth FE videos, it's kind of vagary. It's
Oh,
kind of like
yeah,
you see,
here,
like I've seen videos say, like where it shows a rocket with a camera on it, and all of a sudden the rocket just stops. It just kind of stops, and then it begins its downward trajectory.
right,
So again, but then again, that is only conjecture to say, oh, it
right,
hit something.
exactly.
So
And the other thing,
did it run out of fuel? Did something malfunction? I mean, so it's just,
well, how did it stop spinning so fast? But the
yeah,
camera looks
again,
glitches at that moment. It looks like there's like a glitch in the camera, so you don't necessarily know. So I wouldn't say that's a valid piece of evidence. It's
yeah,
intriguing. It's curious. Well, a hot air balloon. If you were able to take a high altitude balloon and see if it was like scraping across, but interestingly, when you do some of those you see people who do those high altitude tests, um, the horizon looks and stays flat and remains about eye level, the same, the entire time. And you go up higher than they say. Some of these NASA photos begin to show curvature, and the amateur high altitude balloon footage doesn't show the same curvature that's claimed to be visible in some of these NASA photos. Another one that's really interesting is that Elon Musk red car that he sent. Everybody wants to think he sent a car up into space, and yet the live stream glitched, and you could see the projectors in the background, and the curvature was so much sharper of a curve at a lower altitude than it was an absolute farce. And then you see um, but back to your question about how to prove the dome and all that, I think the most intriguing thing that you can do right anytime you like with your eyes is go out and look, and where does the blue start? If you see a cloud, it's in front of the blue. If you see an airplane, it's in front of the blue. If you see the moon, it's in front of the blue. Um, so where's the blue? And it goes back to why is the sky blue? And it's kind of a cool little brain exercise. And yes, I know the globe model has, okay, that's because of the high upper atmosphere and the neon gases and how they're acting inside of the electromagnetism and all this magnetic field stuff going on. And so reality is when you go to try and get hard proof like that, you got to try and find stuff that is accessible to your average Joe that doesn't have a NASA budget or a high altitude balloon and this kind of stuff, which is why that P90 camera stuff where you're looking at stuff that's really, really far away and people are shooting lasers across water and things like that. These are the types of tests that show or perfect mirror reflections over salt flats and things like that that are so far away, or the sunset reflecting off the flat water. These are the little things that convince most people, like, well, it looks flat. This is what I think even Keith was trying to get to. It's flat because it's flat. Well, you can't just say that. You got to say why does it look flat to you? And when you go over vast bodies of water and things like that, visually it looks flat. I mean, even on a globe model that's supposed to look flat because it's so big, right? Well, but it looks flat. And then how much of looking flat will it have to be before, like, at what point, and it's a perfect question, at what point does that curve, when do you start seeing the curve? And so then people go try to find curvature and they can't find it. And the only way to find it is either a fisheye lens, CGI NASA, or and then they'll get confused in all these things.
Again,
Yeah.
even, I'm going to say this, and, okay, to be intellectually honest, as far as my understanding, I like the whole thing with the okay, every picture of Earth from space, or everything is CGI, it's faked. I don't necessarily believe that it's faked. CGI is in use, yes, and I've actually read up on it, and they do utilize all of the space agency. It's not just NASA. In fact, when people just pick on NASA, that just tells me that they're just sucking down the indoctrination of this conspiracy theory. So which is kind of blind in its own way.
No, I think it's all of them. All of them.
Well,
are
okay.
just NASA as just the
right.
American version of all the space
But it only
programs.
goes so far, because I mean, I could go buy a personal in fact, I'm going to do that. I'm going to get a telescope, and I mean, everything else is spherical. So I mean, again, without trying to kind of twist it back, without trying to just you know pinch everything in a certain direction here. I mean, you can look through something, you can look through a telescope, or you can go to your local observatory, and it's all, everything else is spherical. I mean, you could see kind of like when it does go on the darker side, you can actually see that. Anyone can.
Sure.
It's so.
Sure.
But
even if they're all spherical, the Earth, even if all the celestial bodies are spherical, the soccer ball's a sphere, but the field is still flat. So
not necessarily. No, not necessarily. I mean, that's an assumption. That's an assumption.
That's the black swan fallacy. I think that's the black swan.
That's
if you see 10 white swans, you've got to assume the next one's going to be white, not black.
Yeah,
and you're not only assuming it's going to be black, you're assuming it's going to be a
not necessarily, because
puppy.
Not necessarily, because what I'm saying is, if you're playing billiards and you see all the balls on the table are all spherical, yes, it's fair if you're thinking like in the globe view model that, okay, that's just another Earth out there, or that's just another celestial body. That would assume that the Earth is a celestial body, but what I'm saying is that all those balls, the Earth is a different type of thing. It's not the
Well,
same
that's
as
Okay,
celestial
no, no,
body.
wait. Okay, so you're interjecting that the Earth is a different type of thing. Again, we're
In the
back
plasma
to
model, yeah.
Y replaces X for the sake of Y. Okay, you're just saying that. Well, no, Earth is you're using the pool table thing,
Yeah.
you know. But again, you're introducing concepts. But again, there is no mechanism that is actual the fulcrum point where it's actually becoming, you know, it's one thing is getting replaced by the other. You know,
Well, that's what I
that's
go
not
back
actually happening
to. That's what I go.
just by presenting the concept.
Sure, that's I understand, and I usually focus primarily on presenting the concept because of the fact that the flat Earth concept, uh, that the working theory of the flat Earth model is almost never presented in a way that is even makes any sense. It's usually presented, like I said, a ship falling off the edge of a waterfall or whatever, or a disk floating in the middle of outer space with all the other, like if it is planets and suns and everything out in the universe is spherical, it would be really dumb to think that then the Earth is suddenly the only disc-shaped flat thing. And I've seen people do this, well, how gravity would work, and as you get to the edge of the disc, you would start having to like lean and things like that. Well, you're not looking at it through the right perspective of, hey, if you're just go outside and you're standing and you don't feel, and so basically what you're looking at, and you see the ground is flat and all these other balls on top of it are spherical, so that must mean the earth beneath me looks flat, and so it has to be a big ball I'm standing on because everything up there is a big ball. I think that that's going a little too far. Yes, it might be a reasonable prediction, right? So it's okay to predict that the next swan is white, but sorry, I'm a black swan. And the
it's
flat
so,
Earth
Okay.
is a black swan.
So
That's like
basically, you're just
like,
saying,
oh,
but then you're kind of doing the same thing, you know, kind of the Keithism here. Sorry, Keith, not meaning to pick on you. I respect you, bro, but
okay, no,
you know, you're kind of, you know, you're just kind of saying, well, no, it's flat because it's flat. You are kind of insinuating that.
okay,
You're kind of back to
well,
that.
sure,
I
but
mean,
I didn't intend to
what
do.
is the trigger here? What is the trigger here? What is the linchpin that is going to say, okay, here is the reason that Earth is not spherical and it is actually flat?
Because
Where I'm looking
hmm.
you
for
can't
the
find
reason, the
curvature.
actual reason.
Because you cannot find curvature.
No,
When
But that,
well,
that's assumed. That is still, you know what? That is still assumed. Even
any amateur.
I'm gonna say something blasphemous. I'm gonna say something just completely just naive, childlike naive, and almost like, oh my god, I can't believe you said that. But you know what? Even every picture of Earth from space, from the space agencies, is not proven. None of it's proven fake. It's all conjecture. It is literally all assumption. It's assumed to be fake out of the anti-establishment paradigm that comprises a conspiracy theory.
It's not necessarily true at all because if you
Well, not
look at
necessarily.
some,
How is it not necessarily? I mean,
well,
we're
hold on,
still in this gray area. We're still
sure,
kind of just
I know it's very hard to get out.
insinuating. Yes,
NASA
please.
admits that their photos are CGI,
They do. They do. They do.
and so then you're
but
saying there's
see,
nothing proving that it's CGI, but then they admit it's CGI.
Okay.
And then
Well.
the one thing
Mhm.
that's really interesting is when you see the difference in the size of the continents. Like North America, one year on their globe picture is like this, and then the very next picture of Earth from outer space in the next year, the North American continent suddenly got bigger. And I've seen someone be like, "Oh, hey, look, I can do that with my own picture of it on a ball on a globe." But then you look at the context around it, and it's like it wasn't convincing. And I've tried that, and
Sure.
it doesn't seem to work that way anyway. But the other thing that goes into it too is then you see like you can zoom in and there's people who have found that there's copy and paste of clouds and things. And so really I think what they're doing in order to make these pictures, and you assume that they're from outer space, like way out far away, what I think they're doing is they're taking low altitude dare I say, satellites. Because I really do. In a flat Earth model, the satellites can't be orbiting the Earth in the way it's told to us by NASA. The space station would have to be in a high altitude plane. The satellites would have to be basically like hanging off of high altitude balloons and things. And we know that some of these things exist, right? So then we go down, and I think they're just taking strip pictures as they go around, and then they're taking these pictures and like altitude, high altitude set, and they're clipping them all together with their computer program and forcing those pictures onto a ball and into the shape of a ball model. I think that's how they're doing it. This is all conjecture. And so when you get to this, it's like, well, it's conjecture on a globe model. There's conjecture in the NASA concepts of it. But this is one of the things I got back to. What was so convincing for me is not just, okay, you can see stuff from so far, and I keep going back to Chicago skyline, and I get it. You have a way why you think it should be possible to see that on a globe, even though it's supposed to be 24 or 2,000 plus feet behind the horizon, to below it. It's still visible, and so when you can see these things from so far away, and you're just like, okay, that doesn't make sense on a globe model that we can see stuff from so far. And then that one thing that was like the first little hook bait that got me into, I'm like, well, why can't we see it? Right. Then you go and you look at every little rabbit trail, and every one of those have a viable, reasonable explanation in the flat Earth model. Some people get stuck because they're like, how could the sun set on a flat Earth? And they don't, and they just say it can't, that's not possible, so they quit and they stop looking into it entirely, which is fine. I understand most people don't even care about like whether it's flat or round. It doesn't affect their paycheck. This doesn't affect my paycheck either, unless I'm saying it probably makes me negative money. If I don't ever tell someone you're a flat earther in a job interview. I haven't done that, but anyway. But it gets to the point where all these little things have these strange coincidences tied to them. All of the NASA programs and space agencies all have the same demonic symbolism on their logos. All of the mathematics of the globe strangely have 666 showing up all over the place. The original proponents of the globe theory were like 500 years ago. Okay, maybe it's a debate as to when that happened, but they were like probably a weird Jesuit Catholic cult, right? And they have some very there's some very questionable things going on there. So you get to the end of each one of these, and it's like, well, if it's just a globe and it's not flat, and we were just ignorant because it looks flat from the naked eye, and so people didn't have spaceships to go up and all this stuff to prove it, and it was so easy to prove, which is what people claim now, then why are there all these coincidental, easy explanations, and sometimes not so easy, but still there for the globe or for the flat Earth model explanation? And then you get into all of it, like people, well, why can't wait? I didn't know until flat Earth study that you can't really go into Antarctica. You can, but only for these little tours. Just skirt the edge and see some penguins or whatever. But it's all controlled by the Antarctic Treaty, which is the longest standing treaty in human history with all these countries assigned to it. Why? What's down there that's so that why can't people go down there? Why can't private companies go down there and mine out some of these vast minerals and resources that they say are there? And okay, you get to that, you get to this, and there's always another rabbit trail, and there's always a little bit of a reasonable doubt in the information given to us. Like you said, well, if you could just go up into outer space, wouldn't that prove it for you? I was like, well, wait a second. We have zero-G airplanes that can make it feel like you're in outer space. And
Well, no,
really,
so why then why do you think that most of the world, the scientists, pilots, like hundreds of thousands of people, why do you think they're doing so much to pretend that the world's round when it's actually flat? Why would they be doing this?
so first of all, I don't think most people are pretending it's round. If it, let's just, from my perspective, if it is flat, I don't think most people are trying to deceive and pretend it's round and knowingly think it's flat, but then even airplane pilots, right? They say GPS, well, they call it global positioning system. I think it's ground positioning system, and you're just using, you're triangulating between, radio towers and stuff. Even a compass, for example, like in the old days of circumnavigation, I've had people say circumnavigation is not possible on a flat Earth. And it's like, well, if you just go west, you're basically making a giant right-hand turn. And if all you're doing is looking at your compass on an ocean and the compass is just pointing perfectly west the whole time, it'll feel like you're going straight because the turn is so subtle. And every time you look at your compass, it's still pointing straight west. And you can do this with a magnet, a circular magnet, and you can put a real compass next to it. And as you move the compass around it, the north, the arrow pointing north will always point to the middle, and so you're basically circumnavigating with that. So they don't need to necessarily think that they are lying or circumnavigate. And for an airplane pilot, they don't, like I said, most people don't even, it's not even on their radar, so to speak. They're not even, they're just looking at their dials and they're looking at all these, they don't have to understand how the instruments work.
How come we have no picture? How come there's no pictures or video of, an actual flat Earth?
I think there are. You just, first of all, if it's flat and we're in a dome, you can only go up so high. Okay, you can't go and just keep going up and up and up. Eventually, you're going to hit the ceiling.
So we should be able to hit it. They would have hit it by now. Someone would have hit it on purpose.
I think if it's there, high altitude air balloons hit it and they stop. And they
it would people would soon be missiling this edge to find out.
Maybe that's what they're doing with why are they doing high altitude nuclear explosions? Trying to do what? Break it? See what's on the other side? I don't know. I don't know the explanation, but I think that's up there. And to answer your question, based on the altitude of it, there are pictures of high altitude photos of Earth from a high altitude balloon. And there's a lot of them out there, amateurs. They're just really hard to find because it's so oppressed. Just like if you look up YouTube, why the Earth is flat, you're going to have to scroll down for like 20 minutes before you see one person who's actually a serious flat Earth proponent. Most of it is going to just be making fun of 15 reasons why the Earth has to be a ball, 100 reasons why it's not. And you're not going to find books like Zetetic Astronomy or things like that are out there of people who are actually validly trying to explain it. So it's all oppressed, but there are photos where you go up that high, and when you look out, it looks flat, and the horizon looks to be at eye level and goes around, and the sun looks like it's really far away and small, and it looks like there's a hot spot below it on the clouds and stuff. And I don't have these photos. I mean, go try and look them up. They're out there. So that's what you get when you try and get a real picture of flat Earth from really high up. You can't just go and look and see the whole map.
Yeah, I've seen a lot of these videos where it's interesting because a lot of these, like the hot air balloon videos, where they're going way up there, and it's funny though, and this is kind of like we're talking about CGI, and
Sure.
the irony is oh my God, the flat Earth groups and even on YouTube and everything. I mean, the amount of picture and video deception is astounding within flat Earth as a community in and of itself, because it's like you see, like when the cameras are going way up high and everything, and then it's spinning around and the camera's jostling, and and you can't, the latency, you've got a latency effect with the aperture of the camera cannot keep up with the motion. And so you're also see frames where the Earth is flat, it's round, it's concave, it's kind of all over the place.
Well, if you have a fisheye lens,
yeah. And of course, it gets cherry picked, and it's just like it winds up being a meme on flat Earth, on one of the flat Earth groups, and it's then of course they'll show flat and concaved, and I'm like, that's just
Yeah.
playing. That's every bit as bad as you are saying NASA. You know, it's
Right.
interesting.
Yeah, and I have seen some of that where, but interestingly, like with that fisheye lens effect, one of the examples that I like is that Red Bull jump, because now we're talking about um the people who made a video with no intent to do any kind of deceiving or anything. They were just trying to do a really cool stunt and have this guy jump out of uh uh whatever it was, I don't know, some kind of craft from as high as possible. And it's really interesting because when you look at the video of him about to jump outside, it's clearly a fisheye lens because the you can see the craft itself has a metal appendage on it coming off, and that is bending at the same rate as and so it looks like he's jumping, and it looks like what he is looking at would be a curved thing. But then it's like, okay, it's a fisheye, but how can you prove that? Well, if you rewind the video back and you can see there's a camera inside of the craft looking out as the door opens, and the horizon there is perfectly flat. So why? And then and the other thing you'll see is these high altitude balloons. That's we're trying. Okay, there's people don't have the money. I don't have the money to go to a high altitude live stream video of that thing going way up and calculating how many feet up it is, and then show it uncut and make sure it's there. I mean, I wish I could and go up there, and they'll go higher and higher than they say, and then you compare the elevation on that photo to a NASA photo at the same elevation, and the NASA photo shows this big old curve, and all these different photos. And by the way, they can't even get their curvature elevation right. The like, remember that Elon Musk car? The curvature was like, oh, it looks like this at an altitude that was way lower than a NASA photo where the curvature was like this. I don't have the numbers memorized, but then you can see high altitude balloons that say that are measured and claim to go even higher, and it's still perfectly flat horizon. So, but now, like, it's fair because then you just turn around and say, well, that could be CGI too. What if the flat earthers are doing CGI and all this? Well, it's a bunch of amateurs that really, if they got caught doing CGI like that, I mean, it could screw with it. So they're trying to do the best they can. A lot of these people to be as faithful as possible, or like the laser over water, right? The only time I've ever seen the laser test over water appear to show the boat dropping was on the Discovery Channel or National Geographic one, and they had this like cardboard stick thing they were holding up in a boat, and they're like, "Look, I'll draw a line where the laser hits, and then we're gonna go further away, and now the laser hitting up here. Oh, yay, cool." Well, that's the only time I've ever seen that type of thing. And when amateurs go out with these super high powered green long lasers and they go find a spot on the water somewhere where it's as big of the distance as they can across this and that, and they'll take that laser and try and go as low to the water as possible and shine that laser at this is one of my favorite proofs, actually. They can go almost to the little surface of the water and point it, and they'll just flicker it back and forth at the camera until they can see the flicker in the camera. They're like, yep, I can still see it. How high? Oh, I'm about 10 feet up. All right, go down. Can still see it. Go down. Can still see it. And using even the correct calculus of that light should, and there's a curve. If there is a curve, that light should not be there. And the only way for that atmospheric lensing to bend it around the curve would be to shoot it upward first and then let it bend up and around, because the light is bent downward. And so if you're shooting that light perfectly straight towards the horizon and it's curved and it's bending down, okay, I guess you could try and say it's bending down and around the curve, right? But if it's bending down, eventually it's going to bend down into the curve. And on a flat surface, it bends. So it would need to bend on a globe model perfectly like the light is orbiting around, right? But on these models, you can always see the laser. and you're not supposed to be able to see it, even on these dry surfaces and deserts. And then you see perfect reflection on water or that strip of
See,
sunset light coming, and it's just all these
but,
little things. And those do-it-yourself ones are really the ones that get people the most, because it's like, okay, I went out and did it. We could see the laser, and according to the mathematics, you shouldn't have been able to see the laser.
but
And then you get
refraction works.
sunset. How does that work? And then you have to kind of do a little research and reasoning. And I think there's some reasonable explanations for how some of that stuff occurs as well.
But refraction works as the light enters. It works as it changes from one state of matter to another. When it's inside that state of matter, it doesn't refract. It'll go straight, dead straight. So if you look at how refraction works, it goes inside glass and then it refracts. But if it's inside the glass already, or if it's outside the glass already, it doesn't refract until it changes from one state to another.
Sure. Well, then you're talking about temperature, because it's not just the humidity or the water droplets. It's going to have temperature differential and things like that. For example, I like the people ask, how is it possible for a sun to set? And then you just go, well, go out on a really flat blacktop on a hot day, and you're gonna and have some and put your eye down or put a camera on the ground, and then walk away from it, and your body is gonna appear to set. It'll disappear feet first, and as you do, visually to the camera, your body's not gonna look at a certain point. It's not gonna look like it gets smaller anymore. It's gonna look like your body stays the same and just goes like that. So, I mean that for me, even if you want to, go reason out how that could work on a globe model, that reasons out enough as to how it's possible on a flat Earth model. And so at that point, I'm like, well, it's possible on a flat Earth. Of course,
You'd have to
people
show.
assume it's possible on a globe, but
You'd
if
have
it's
to show the
possible on a
model
flat
of the
Earth, then I
different.
haven't had the flat Earth debunked yet, in my mind.
You'd
You know what
have
I'm
to
saying?
show the model with the different levels of um, water droplets or different levels of heat, just to show how it could possibly like bend down like that, because it normally goes straight until it changes a really different state of matter. So if there's
Sure.
water, if there's thick air, if there's heat, if there's usually heat,
Well,
heat,
yes,
heat.
and so there are variables as well, which is why I have seen. I always say, I tried looking up the other day, sunrise over Everest, because I wish I knew which video I had originally seen it in, but there's certain times where you can see sunset doesn't look the same every time. There's times where you can see the sun appears to go bigger to smaller, or a sunrise looks like it's getting small and coming at you and getting bigger. Now someone could just say, well, that's just because the light rays are brighter as they get closer to you, and so it looks bigger to the camera, but that's not. But no, I've seen videos where it looks like the sun is right overhead really big and then goes and like that, woof. It looks like that from high altitudes where there's less atmospheric water lensing stuff going on, or like over a desert and things like that. But I don't have the budget to go, and definitely not interested. I mean, I used to think climbing Everest was a cool concept until, I realized how many people die on that thing. So, it's really, and again, the high altitude air balloon, when you go up there, you'll see videos of like the sun looks smaller, and then it looks far away but really small, and then there's like a hot spot below it, like directly underneath it, instead of like just the way we would assume it might look on a globe model. And then, like, why does NASA have to use so much CGI? Why does it have to fake all this stuff? Can't they just go
But
up on the moon and plant a
I don't think
camera
NASA's
in it?
actually. The thing is, I don't think NASA's actually faking things. I don't think it's with the intent of faking things. I think because I know it's going to sound naive, but I actually did watch a video on this, and they were explaining the use of CGI in terms of like color. They use it for because it's like what they're getting, especially like from outer space. It's not all this brilliant color that we're seeing. It's
Sure,
very
but why
gray,
not
very
show
scale.
it
It's like
for
scales of gray, and it's like very non-distinguished. Things are non-distinguishable, so they do spruce. Yes, they do spruce it up. Is it
yeah, but
deceit? They also
Why?
they also do color code for for what they would perceive as in terms of like the different composition,
Of
that the
course they
light
have an
is made of.
explanation. I mean, of course they have an explanation, but why
Well,
do that?
yeah,
Why not
but
use a good
it's
They
not
light?
debunked. It's not
promotion. They've got
debunked.
to make money. They've got to attract people.
Yeah.
Sure, but
They've got to
here's
get
something.
huge
Why is it?
amounts of funding.
Why not just go up and send a robot onto the moon, land it on the moon, which apparently they can land a robot on Mars, according to them. Just put a robot on it, and the same side of the moon is always facing us, right? So then just put a live stream of what the Earth looks like from there, and just
But they
show it, and and
well, they
and
can
and
do
then we
that just
see.
with telescopes now. You just
Well, I
with a
mean, it's
telescope, you
just
can
it
see the
gets
surface
a
of the moon.
little. It just gets so like why NASA is having like why is there so much theatrics and then there's they claim that they're on Mars and then all of a sudden you see a landscape exactly the same out in the desert somewhere on Earth, or everything they bring out, space bubbles in space and all, and there's always an explanation, but for them, but it gets super super suspicious. Even the first supposed picture from of Earth from outer space, there's like leaked footage where it apparently they were just blocking out all the light on the inside of their thing and blocking a hole in their window so that it looked like a Earth, and they were inside the shuttle shooting at it. NASA can't even come up with whether there's stars in outer space or not, whether they can see the stars or not. Interviews with astronauts that are supposedly out there, some of them say, "Oh yeah, the stars were so brilliant and amazing," and then other astronauts say, "No, you couldn't see any stars." So it just gets really suspicious, and especially then you turn around and it's like, well, I see a lot of other things where all these, it doesn't, it looks flat. And so then people try to measure it and they can't find measurable curvature. And then you can see stuff, like I said, and yes, there's somewhat of an explanation about how the light would have to bend around that curvature. Okay. But then you're saying the light is bending almost perfectly along the curve, just
It
perfectly
well,
through it.
no, it doesn't like bend like that. It bends straight, straight, straight. Like light doesn't. If you look at diagrams of refraction, it hits like another level of body of matter, and
Sure,
then
like a water
it'll refract
droplet.
more. It
Yes,
doesn't like suddenly. It doesn't like slowly curve. If you know what I
sure.
mean.
Well, I would probably disagree with that and agree at the same time, okay? Because if it's water drop, because I've had people tell me it's humidity in the atmosphere that causes
Mm.
the light to.
Humidity,
It's
heat.
water droplets in the atmosphere, not the humidity, but actual physical water droplets. And then had someone say, no, it's because light bends because of the temperature differential between them. Well, what
Well,
if it's all
yeah,
of them? And if it is
it's
water
all of them.
droplet,
Yeah.
like mist, then you're talking about the light hits this water droplet, bends a little bit, then this one bends a little bit, this one, and they're so close together that eventually it's going to look like a smooth curve of that light, because the water drop, it's not like, oh, we're hitting the humidity level in Texas, and then all of a sudden you move over
Well,
to
it's
one
not. It,
state, and now it's a whole new humidity level, and so it goes straight through Texas, then it goes down, and then it goes
but
down a
it's
little. I
it's
think it's
quite.
a lot
If
of
you just look
droplets.
at if you
You
so if you just look at a picture of the moon, you can see that the light is virtually almost exactly straight because you're going to see a picture of the moon. You're not going to see light all over the place. Otherwise, you'll go outside, you won't be able to see anything. So the light is virtually dead straight, and it changes on angles. It's because otherwise you wouldn't be able to see anything outside
no,
past like 100 feet, or
no, I
because the
don't
light would
think
just be
that's
dispersing everywhere, if you know what I
I
mean.
think this
no.
is where we're starting to play with perception.
It's yeah.
Yeah, I don't think that would be the case, and especially if you're looking at the moon. I mean, people always like with the moon, for example, you'll say, well, people always say, why does it look bigger on the horizon when it's low in the sky. Well, the explanation, and it also looks colored, like orangey or whatever when it's low like that. I think it actually probably is visibly a little bit bigger. And then as it moves, in my opinion, towards us, and comes around and it gets directly above, now there's less atmosphere between you and the moon, and so it's not going to be magnified. It's not going to be it's not going to have anything causing it to change color, and so you just see the white light, which is actually bluish and a different tint and color than the light from the sun, and a different quality of light. I've heard that, and I think that there's a little bit of a confusion out there as to how to properly do this experiment. But there's a claim that if you go moon shadow, right, and you go into the shadow of a moon, or like the moonlight's coming down, and there's moonlight hitting the ground here, and here there's a shadow because the tree's in the way. That actually, if you're in the moonlight will make it colder, and in the shadow, it'll be warmer than but in the sunlight, if you're in the shade, you're cooler, and it's hotter in the light. But moonlight is opposite of that. There's, for example, moonlight will one, I don't remember which one it is, moon or sunlight. One of them rots things and makes it more rot and petrified. The other one preserves it. So it's two, and they're the moonlight. I actually looked at the spectrum of the color of the moon, and also, I mean, if the moon is so bright like that, it doesn't seem to be that bright in the photos from NASA on the moon. Apparently, it seems like a grayish color. And so there's all these weird little things that come up, and you're like, well, I guess. And then, but no one's ever heard these. Usually, no one's even ever heard these little reasonings of like, well, why that, why this, and people seem to be so desperate to cling onto globe model that they just completely dismiss flat earth explanations or concepts at all when it's presented. They just completely ignore the alternative, which is why I so much appreciate what you guys are doing here. I don't even necessarily it'd be cool if somebody was convinced somebody, but I am actually under the opinion that no one person can convince another person of anything. People have to choose for themselves what they believe and why. Even biblical faith, you can't make anyone believe anything, no matter how much truth. It's only God that can reveal the truth of the Bible to an individual. He picks who believes when, and he's the only one that can give them that faith. Well, in a flat earth model as well, in the flat earth globe debate, it's not my job to convince anybody, really. I mean, I'll try and give reasons why I believe. I'll try and say what are reasons that I think are convincing to me, but something that's convincing to me might not be convincing to somebody else. But my goal is to at least present both sides, have the other side presented and heard in a way where it's intriguing enough to allow flat earth proponents to feel like maybe there's one other person out there saying things in a way that made sense to me that I can't necessarily explain it. And then I've had so many times where I hear people, and I appreciate here that there's no like mocking and ridiculing and things like that going on, which is fantastic about this channel and what you guys are doing here. But there's so much demonization and mocking of flat earthers that goes on. It becomes, instead of a debate club type thing, which is kind of fun, it becomes a clown show,
beat down.
beat down, where it's just fun to make fun of people because they think it's flat. And I find that those people are the ones that are most ignorant about what the working flat earth model is, are the ones that mock and ridicule people for that view. I mean, I've lost friends and family over just answering questions about flat earth, and so it's difficult when people have so much disrespect. And I think the reason that there's so much disrespect for flat earthers out there is because people don't even give it a chance. People don't even think about it from that angle. Don't even think about why. It's like, how could anyone ever possibly believe that, ever? Instead of, well, why do you believe that? Which is what you guys are doing here, and I appreciate that. Even if you're not convinced, It's fantastic. I know we're running low on time, and I've taken a lot of it.
Yeah,
but
I'm gonna have to.
I
I'm
think
gonna
I
have
think
to
it's
go to bed.
important. I think it's important to, like I said in the very beginning, my stance is just more psychological. It's more understanding why we adopt these concepts, and that's the thing. I'm interested in why. I keep mentioning like trigger points, like what is the nucleus? What is the what is the thing that is making us question things?
Where's the red pill?
Yeah, there we go. There we go. Yeah, exactly. Blue pill or red pill, right? But no, I mean,
I-
blue
I'm
pill.
gonna
Don't be
have
ready
to.
for this conversation.
I'm gonna have to. I'm gonna have
oh
to
yeah,
go.
yeah. Well,
I
let's
have
talk
to
about
leave
the
you
patients.
guys.
I love that.
I'm gonna
I
have to leave you. I'm gonna
till.
have to go to sleep. I'm gonna
Okay.
have to leave you and go to sleep. I'm afraid.
That's fine.
I think we should
you-
all maybe
this is-
wrap it up.
This has
Yeah.
been absolutely awesome. I would love. See, I love the film. What's the film with Jim Carrey where he finds out he's in a sphere? What's
Yeah,
that film?
Truman Show.
I'd love to know. I'd love to
Yeah,
find out. If you could convince
don't-
me, I'd be a happy man.
Hey,
Yeah.
maybe they'll open up Antarctica to the public one time, and I'd rather book a shuttle to the edge of the Earth than a shuttle to the supposed outer space. So we'll see. Maybe maybe one day. Who knows?
I think
up
you'll
there.
be going around. I think you'll be going around in circles to find that edge. Just
Well,
so
yeah.
you
Just
never know.
do me a favor. Don't fly straight south in a plane.
There we go. Don't do that.
All right. Well, hey guys,
No,
I
it's
appreciate it.
all
I'm
good.
gonna
I
let
think
everyone go do it.
yeah, I think in closing, I just want to say, it's good to question things. I think that this can manifest itself in unhealthy ways too. I think people can really kind of lose themselves in things like this. I mean, I think it's beneficial to question, but I think it's also beneficial to make determinations and be able to move on and free yourself from, certain aspects of life. Always being cognizant, always being aware. I actually had a friend that would say, he was more literal than me. He was like very, very literal about everything. And he always used to tell me, do not go through life wearing rose-colored glasses. And I'm like, you know what? But I challenged him on that one time. I'm like, you know what? Maybe try putting on the rose-colored glasses from time to time and enjoy your life.
Yeah.
Just be a little happy. Don't be so like, I know the truth. Everything is lies. And I mean, just like, no, I don't. Why would you want to be like that? I'm not saying be stupid. I'm not saying be dumb. I'm not saying be unaware. I mean, I'm saying be cognizant of your surroundings. Be understanding of the world around you, but don't be afraid to make a determination on that and just go on with your life. And go fishing. Just do something to enjoy yourself. Because when it comes down to it, when it comes down to it, we're only here for. I mean, we've only got a few years, man, and it can end at any time. I just actually had an ex-girlfriend that I found out passed away not too long ago, and I'm like, oh wow. It just puts it into perspective to where you're just like, this shit goes quick, it goes really quick. So it's fun to dabble in these things. It's fun to explore, and by all means do that. But don't get lost in it, and don't wind up being that person that has 79 cats and you're whispering in people's ears for fear the government will overhear you. Don't don't lose yourself. That's my point.
Appreciate that. Well, Brad, thanks a lot. Francis, great to meet you. I'm gonna check out right now and go take a nap. Like I said, I've been pretty under the weather, very sick. So hoping I'm feeling better. Great to talk to all you guys. Keith as well. Sorry your video wasn't working. John with L Fox Studios, always a pleasure, and appreciate all you guys. I will
Keith.
out.
Keith beeped.
Goodbye.